Hello everyone, myself Vinay Kumar. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics, then please do subscribe to my channel. So now we were looking into the 8th chapter of 9th standard mathematics, that was on quadrilaterals. And in my previous video, I had explained two questions from exercise 8.2. So now there are four more questions which are remaining in this particular exercise 8.2. So now we will try to solve the next questions which are left in this particular exercise 8.2. So in exercise 8.2, we will move on to the third question. So if you want explanation for first and second question, you can refer my previous video. So in third question, they have asked to prove a particular rhombus inside a rectangle. So here they have given ABCD is a rectangle. So first let us draw a rectangle. So this is a rectangle. So we have a rectangle like this. And here this point we can name as A, this as B, C, D. So here P acts as the midpoint of AB. That is, if you consider this line as AB, so this is the midpoint of AB and this point is P. For BC, if you choose midpoint, you can name that as Q, R and S respectively for CD and AD. So now for CD, R is the midpoint and for AD, S is the midpoint. And all these midpoints are connected with each other like this. So I'm just connecting P, Q, R, S. So basically like this it looks. So here you have to prove that this PQRS quadrilateral which is forming inside a rectangle is a rhombus. So what is the definition for rhombus? All sides of a quadrilateral, if they are equal to each other, then it is a rhombus. So basically you need to prove PS is equal to PQ is equal to QR is equal to SR. So in order to prove this, we will try to draw diagonal for this particular rectangle. So we'll draw the diagonal BD and we'll draw the diagonal AC. So one more thing you should remember, diagonals in a rectangle are always equal. So now here you can consider ABC triangle. So that is this particular ABC triangle. So we have ABC. So now we can consider this ABC triangle which is there like this. So here this is A, this is B, this is C. So AC is diagonal. And here P is the midpoint of AB which is there here and Q is the midpoint of BC that is there here. So now you connect this PQ. According to midpoint theorem, PQ is equal to half AC. So now here consider triangle ABC. So consider triangle ABC in which P and Q are the midpoints. P and Q are the midpoints of AB and BC. So therefore here this particular PQ is half times AC. So therefore PQ is equal to half times AC. This we have seen in midpoint theorem. So if you want to understand midpoint theorem and converse of midpoint theorem, you can refer my previous videos. So from midpoint theorem, we know that PQ is equal to half AC. Now I'll consider this particular triangle ADB. So I'll consider this DB diagonal and I take ADB triangle. So now let me draw that particular triangle. So we have a triangle like this. So this point is A, this point is B, this point is D. So ABD is the triangle, and for AD, S is the midpoint, and for AB, P is the midpoint. So now similarly, how we solved for the previous case, like that you can solve here also. So consider triangle ABD, and here ESP is connected. In triangle ABD, S and P are midpoints. So S and P are midpoints of AD and AB. So S and P are midpoints of AD and AB. So therefore, SP is equal to half dB. So SP is equal to half dB. So this you can call as equation 2, and this you can call as equation 1. And this is also from midpoint theorem. This is also from midpoint theorem, or shortly you can call this as MPT, that is midpoint theorem. So now we have SP is equal to half dB. Now I will consider this lower triangle DBC by considering DB as the diagonal. So let me draw DBC triangle here. So here we have DBC as the triangle. So here this is D, this is B, and this is C. If you consider triangle DBC, R and Q acts as the midpoints of DC and BC. So here RQ is equal to half dB. So this particular RQ line will be equal to half of dB. So this you can call as equation 3. And now we will consider this particular triangle ADC. So here S acts as midpoint of AD and R acts as midpoint of DC. So here also you can consider triangle ADC. So here S and R are midpoints of, you can write midpoints of AD and DC. So therefore, here equation 3 also I have written based on MPT, that is midpoint theorem. So here also in this particular triangle, SR is equal to half times AC. So SR is equal to half times AC. This you can call as equation 4, and this is also according to MPT, that is midpoint theorem. So now we will write all 4 equations together. So here we had first equation as PQ is equal to half AC. So PQ is equal to half AC, and we have second equation. So in second equation we have SP is equal to half dB. So here SP is equal to half dB. So this is according to equation 2. So in equation 3 we have RQ is equal to half dB. So we have RQ is equal to half dB, and in equation 4 we have SR is equal to half AC. So here ABCD is a rectangle. So here ABCD is a rectangle. So since ABCD is a rectangle, therefore here AC is equal to BD, because in rectangle diagonals are equal. So always remember, diagonals are equal in rectangles. So in rectangle diagonals are equal to each other. So AC is equal to BD, or you can write this as AC is equal to DB. So if you are writing AC is equal to DB, then your equation 1 becomes PQ is equal to half AC, can be written as half dB, because AC is equal to dB, and equation 2 is SP is equal to half dB. So SP is equal to half dB, and equation 3 we have RQ is equal to half dB. So equation 3 is equal to RQ is equal to half dB. And what about equation 4? In equation 4 we have SR is equal to half AC. So AC is nothing but dB, so half dB. So here you can see we have same RHS for all 4 equations, that is half dB. So half dB, half dB, half dB. So that means PQ is equal to SP is equal to RQ is equal to SR. So therefore PQ is equal to SP is equal to RQ is equal to SR. So therefore PQRS is a rhombus because all sides are getting equal to each other. So therefore PQRS is a rhombus. So this is what they had asked to prove in this question, and we have proved that. Now we will move to the next question in this particular chapter, that is fourth question. So in fourth question they have given one figure, that is a trapezium. So let us draw this particular figure. So basically they have given a trapezium. So here A, B, C, D is a trapezium. So here we have a trapezium like this. So A, B, C, D is a trapezium, and here this particular AB is parallel to DC. So AB is parallel to DC because one side in a trapezium should be parallel to each other, and BD is a diagonal in this particular trapezium. So they have drawn BD as a diagonal, and here E is the midpoint of AD. A line is drawn through E parallel to AB intersecting BC at F. So here they have given midpoint of AD. So midpoint of AD is E, and there is a line drawn through this E parallel to AB. So they have drawn a parallel line to AB through E, which is intersecting BC at F. That is, this point is F. So there is a line intersecting at F, which is also passing through the midpoint E. So now another data what they have given is this line is parallel to AB. So now based on this particular data, you need to show that F is also the midpoint of BC. So in order to show F is the midpoint of BC, we will consider this particular point as G. So consider this particular point as G. You can see here clearly we have two triangles, that is one is ABD and one is DBC, because we have drawn a diagonal in this trapezium. So we have two triangles. So first let us consider the triangle ABD, that is this particular triangle. So here we have a triangle like this. So this is A, this is B, this is D. So here we have a line passing through this at E point, and here we have named this point as G, and we know that this particular line is parallel to AB. That is basically EG is parallel to AB. So now consider triangle ABD. Here EG is parallel to AB and E is the midpoint. E is the midpoint of AD. So if this is the case, then straight away we can use converse of midpoint theorem, that is theorem 8.9, and we can conclude G is the midpoint. So G is the midpoint of DB. That is, here G becomes midpoint of DB because E is already midpoint of AD and EG line is parallel to AB. So straight away using converse of midpoint theorem, or you can call this as theorem 8.9, or you can call this as converse of midpoint theorem. So if you want to understand theorem 8.8 and 8.9, that is the midpoint theorem and converse of midpoint theorem, you can refer my previous videos. So according to theorem 8.9 or according to converse midpoint theorem, converse of the midpoint theorem, G becomes the midpoint of DB. Now we will consider this particular triangle DBC. So now we will consider triangle DBC. So we have a triangle like this, that is, this is D, this is C, and this is B. So DBC is one triangle, and we have G point over here, and the line is passing like this, and here we have F. So here already we have proved G is the midpoint. So consider, and since AB is parallel to EG, or since AG is parallel to that particular line which is passing through E and F, and AB is also parallel to DC, so automatically this particular line EF or this particular line GF becomes parallel to DC. So here consider triangle DBC. Here EF is parallel to AB. So EF is parallel to AB, and AB is already parallel to DC. So therefore EF is parallel to DC, or you can write this as GF is parallel to DC, because G is lying on the EF line. So that's why in the place of writing EF, I am writing GF parallel to DC. And we know that, and we have proved G as the midpoint. So we have proved G as the midpoint, of this particular DB line. So we have already proved G as the midpoint of DB. So therefore F is the midpoint. So therefore F is the midpoint of this particular line BC, because here G is midpoint, this particular GF is parallel to DC, so automatically F becomes the midpoint of BC. So F is the midpoint of BC. This is according to converse midpoint theorem, or you can simply write theorem 8.9. So if you want to be more clear, then you can write converse of midpoint theorem. So this is what they had asked to prove in this particular question, and we have proved that. So this is all there in this particular video. There are 2 more questions in this particular exercise 8.2 that I will be teaching in my next video, and there this particular chapter comes to an end. So like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.